Now we're going to talk about root behavior of polynomial functions and other polynomial graphing stuff. Very fancy title. So first, we're going to talk about multiplicity and root behavior. Really here we're summing up the, or going over the conclusions from the graphing activity, from the learning activity from last time. You should have noticed that if the multiplicity of a root is even, then the graph touches the x-axis without crossing there. If the multiplicity of the root is 1, then the graph crosses the x-axis with no wiggle there. Remember, we were calling it a wiggle when a graph does something like this. We'll have a picture on the next page. And if the multiplicity of a root is odd and greater than 1, then the graph crosses the x-axis with a wiggle. So let's look at determining a root from the graph. We'll start with a graph. So we've got our function here. This is a polynomial function. It crosses the x-axis in three places. I've got one x-intercept here, one x-intercept here, and one x-intercept here. Now remember that the x-intercepts are the real roots of a function. A function might have other roots that are non-real complex roots involving imaginary numbers, but and those won't show up on the graph, but any real roots will always be x-intercepts for the function. So I've got 3 real roots here. So my 3 roots are -3, 1, and 4. Now let's look at these one at a time. -3, this has that wiggle that we were talking about, which means that the multiplicity of -3 is odd and greater than 1. There's no way to know just by looking at the graph if it's a 3 or a 5 or what have you, but I do know that it's an odd multiplicity that is greater than 1. My next root was a 1. This crosses the x-axis nice and smoothly, so I do know that the multiplicity of this root is exactly 1. And here I have at 4, the graph touches without crossing. And so 4 has an even multiplicity. And doesn't have anything to do with the roots, but notice that both of the ends of this graph go in the same direction, which means this function has an even degree. The degree of that polynomial is even because both ends head in the same direction. Now let's talk about turning points. Here's my picture of my graph again. A turning point is a point where a function changes from increasing to decreasing or from decreasing to increasing. Remember, you might want to review when we were talking about quadratics. When we were talking increasing and decreasing, we always mean as we read the graph from left to right. So even though this arrow is pointing up, as I read from left to right, this is decreasing. And we will always read increasing and decreasing from left to right. When I specify where a function is increasing or decreasing, I'm always going to give my answer in terms of intervals of the domain. So what I'm looking at are the x-coordinates. So this function is decreasing from -infinity all the way to this point right here, which I've labeled the x-coordinate is -0.414. Then it's increasing from negative 0.414 all the way to 2.414. Then it's decreasing from 2.414 all the way to 4. And then it is increasing after that all the way to infinity. So we can list these out. So, like I said, the function is decreasing on the intervals from negative infinity to negative 0.414. That was this part of the graph. And it's also decreasing from 2.414 to 4. Then it's increasing from negative 0.414 all the way to 2.414. And it's also increasing from 4 to infinity. And our new vocabulary word of a turning point, if we're looking for where it changes from increasing to decreasing or from decreasing to increasing, I have one change here, one change here, and one change here. Now, these are only going to be things that we read from the graph. To be able to find the turning points of a function without a graph requires calculus. You do have some homework questions that are asking you for turning points. It asks you to use a graphing calculator. You can use the Desmos Online Graphing Calculator, and it will even allow you to click on a maximum or minimum, and it will show you the coordinates of those points. And that is it for this video.